Hi, welcome back. I'm your instructor, Chris Sikora, and we're looking at week 2 for metallurgy. Those of you who are in the 8-week course, this is technically just the second day of the first week. So 16-week course, you're on target if you're doing this the second week. All right, and many of you know already that as far as, because this is online due to the COVID, this is a theory-based class regardless, so it's really not that bad. You can turn your things in late to me, so don't worry if you get behind. The things that I do want, though, just make sure your midterm and your final get into me on time, and everything needs to be to me the end of the semester. Again, that's in your syllabus on D2L. You can look that up depending upon the class you're in. All right, today, let me go ahead and get started here. We're going to look at chapter 2. And so basically, chapter 2 deals with metallurgy and chemical terminology. And hold on a second as I turn that music off. That was from the earlier PowerPoint. So basically, chapter 2 is metallurgy and chemical terminology. So the reason you need to know basic terminology is many of you will be working in industry, especially those of you in welding. You don't need to have the terminology down like a scientist would, but when they're talking about certain things, because sometimes you will be talking to material scientists when they are working on something that's kind of exotic perhaps, or if you're working with a heat treating company or even just ordering steel, some of these things are very important to know. So like you see the lab down there, that's a metallurgy lab, and if you ever do talk to a metallurgist about a certain application, just want you to know when they start rattling off some of these terms, you have a grasp of what they're talking about, because they're not commonly used for most people. All right, so we'll talk a little bit about the chemistry of metallurgy. Now we're going to look at the composition of metal, atoms and crystals and grains and things like that. It's review for almost everyone. All of you have been exposed to it before, but just note that I will highlight in red or sometimes underlined things that will be on the midterm. So just be aware, if you see those things, note that, because most likely you're going to see it again on the midterm coming up. All right, and also the chemical terms, element, compound, solution, and atom, those are the 4 that we're going to look at, and some of those are actually on the midterm. And then just how to describe metals and alloys, like what's the difference, or I mean, is there a difference actually? That's what you're going to learn about. Okay, first of all, the very basics, the building blocks of metal. We're looking at a diagram of an atom there, and you'll see the protons in blue are positively charged, and they're in the nucleus. That's what you see in the center there. Those electrons are spinning around the outer perimeter, and there's different levels of where they're spinning. All right, neutrons are neutral charge, okay, and electrons are negatively charged. So you have positive, negative, and then no charge, basically, or neutral as they call it. The center, which is the nucleus of the atom, contains just protons and neutrons. You'll never see an electron in there. Electrons orbit the nucleus. And what's fascinating about the electrons on the outside, that's where a lot of the work goes on when what we're going to talk about, and how certain metals have characteristics where they'll interlink between other atoms, and that helps those electrons, what they call valence electrons that spin on the outside, actually help electricity travel and do all these other things. They lock them into I'm getting ahead of myself. Okay, so elements. So we talked about elements. And first of all, atoms are the building block of metals. All right, now an element is a pure substance composed of a single material. So it's just those same atoms. So whatever the atom is, It's just it replicated. So when you see a collection of, or when you see steel, it has pretty much a majority of a particular atom, like an iron atom, and then carbon. And we've all seen the periodic table of elements. I believe there's around, out of all of those, it's somewhere around 95 to 100 are actual metals. And it's debatable on that too. So that's why there's not, if you looked it up, Google it if you like, there's not a definitive answer globally on how many metals there really are, but about 95 is what we're looking at. Okay, and those elements, by the way, remember it's the number of actual protons to neutrons to electrons that actually create that element. Some of those elements, by the way, also only exist for a fraction of a second. So it's interesting to note. Okay, metal is an element that has several metallic properties. Some of these properties we'll talk about: electrical conductor, a heat conductor, hardness, high density, and opaque or non-transparent. Now that doesn't include, like, for example, cobalt can be in a crystal form, so it's actually transparent. You can see through it. But when it's in its crystal form, chemically, we're still thinking of it as we know cobalt by itself is a metal, but so take that loosely. That's what I'm saying. All right. All metals possess some of the above properties. Many metals possess all the properties. All right, a molecule is when two or more elements combine, their atoms join and create a molecule. So, for example, hydrogen and oxygen, when they combine, they have a very nice way of combining, and we know that as H2O, or water, aqua. All right. Now here's the next thing. Now this is on the test, your midterm, and a lot of students get this confused because when I have, like, your test is going to be multiple choice coming up in a few weeks. But basically, I say, what's the building block of metal? And one of the options is it's atoms, crystals, and grains, and then some other things I have in there. Remember, those are usually best answers what I'm looking for. So really the building block is an atom. Crystals and grains are what you get from those atoms combined to make steel. A lot of you probably didn't realize that steel is actually, or I should say iron, it's crystals. It's actually crystals. Metals are crystals. Okay. And here you can see, this is actually a diagram of how these crystals are formed. We'll talk about what these all indicate, but over here to the right is actually a photograph of an up-close picture with a microscope of the crystals. And that crystal formation is everything, just like grain in wood. And those of you who've maybe done a little bit of carpentry in class or at your house, you know, you can break it along the grains, or the grain of the wood. Crystals are different because they don't have that exact type of grain in one direction necessarily, but you can do things to make it stronger and make the crystals larger or smaller, and those have an impact on how strong it is, or how tough it is, or how soft it is. We're going to learn that in class, and a lot of that is just from how it's prepared or heated up and then cooled. Like, how far is it heated up to, and then how quickly is it cooled. The quicker you, but what happens is when you heat it up, the crystals get smaller and smaller, the grains, and so they're really small. Now, if you do what they call a quench, where you dip it in cold water, it's technically, it freezes it in that small little crystal grain structure. And that small little crystal grain structure is very, very hard. Now, if you let it just sit out and air cool, which takes a lot longer, those crystals start to collect into groups. And they basically, the bigger they are, the softer it is. Okay, so when large groups of atoms or molecules get together, they form a family. And They may be large enough to see with the naked eye. Some of you might have seen on sheet metal, sometimes like that's outside, like on a roof, like the corrugated sheet metal, and what looks like crystals and grains, similar to that image. And that's actually a coating that they put over it. You're not actually looking at the steel crystal and grains, most likely. You're looking at a protective coating that's sacrificial coating that's put on it. And we're going to discuss that. I'm going to let you know what that is in the upcoming weeks. All right, these families are known as grains or crystals. Compounds. Now, compound is a material composed of two or more chemically joined elements. Now, here's another. This is where it's a little different. It's a tighter bond, and basically, you can see there that's NaCl, which is common table salt. And what we have when we're looking at those two, they're innocuous when they're together. So you see that little picture right down here of this electron, and it's shared between the two. It's kind of like floating around, and that creates this bond. And it creates a basically a very innocuous thing. Well, not too innocuous, but separated though, chlorine will kill you if you take that in. You don't want chlorine. All right, and sodium by itself isn't necessarily a great thing either, but you put them together and you got table salt. Okay, so the example, sodium and chlorine, both hazardous, can chemically combine to create table salt, which is non-hazardous. All right, now mixtures. A mixture is a material composed of two or more elements or compounds mixed together but not chemically joined. You see it looks kind of gross there. There's some mason jars, and they have someone made like took a coffee filter, and they're pouring muddy, or actually might actually be coffee, into that little jar. I just grabbed that off the internet. And the idea is it can actually filter that stuff out. So a mixture is not chemically joined. So those atoms, like when we saw with the sodium chloride, they don't actually interlock. So you can separate them with the filter, whereas what we saw earlier, compounds, they're not easily separated with the filter. You actually have to heat them up or do some sort of chemical reaction to separate them. Mixtures, you could separate it with the filter. So muddy water is an example. You know how you can filter out muddy water. Or in your refrigerator, or you have the filtered water that's taking out things out of the actual water. Okay, now solutions. Okay, a mixture where one substance dissolves into another. So this gets interesting here. All right, you have what they call dictator. Now here we have highlighted in red. Remember, sometimes when you see these, that's going to be on the test. So I'll probably ask you exactly what you see there. The dictator dissolves its submissive. I'll ask. So imagine this. It's probably going to say, what is a solution? And it'll give you multiple choice. Remember, dictator dissolves its submissive. All right, the dictator is a solvent, which dissolves its submissive, which is a solute. So in this case, again, we'll just use not salt this time, but sugar. Sugar is the solute. It dissolves into water, which is the solvent. All right, we're going to talk a little bit more about that here. So a solid solution now, like what we saw earlier was like a liquid solution. This is a solid solution. Refers to thermally enhanced. So basically it's heated up. So both solvent, iron, and solute, carbon, are solid. So instead of sugar and water, we have iron and carbon. So the solvent is iron, the solute is carbon. It just goes right in and it mixes in. You can't even really see it for the most part with the naked eye. Now that's makes steel, okay, iron and carbon. If you could really hold on to that through this whole class, that's a big deal, because most of the class is about iron and steel, and those two are related. Okay, so heat is required to dissolve them at an elevated temperature. I don't know why I put that in there, but basically we know heat is an elevated temperature. A lot of these are right out of the book, so when I copied them over, I was actually just writing these up, so my apologies if they're a little on the strange side sometimes. Okay, so copper is a solvent as well. It dissolves zinc, lead, tin, and nickel. Those are the solutes. So if you heat up copper, you could make different things from it. Okay, and we're going to see how that makes brass and bronze when you mix those things. But that's not until near the end of the semester when we start talking about non-ferrous metallurgy. And iron, again, just to reiterate, is a solvent, dissolves carbon and other elements. Little factoid. The reason I have these two is because iron and copper are the two most common solvents out there. There are others, but those are the most common ones that we see on a day-to-day basis. All right, so little factoids about alloys. Okay, when two or more metals are dissolved together in a solid solution. That's the, again, this one, I probably have this on the final. It should probably be in red. So I'll probably ask that. Okay, steel is an alloy. Oh, by the way, there's two things here that you gotta know. Steel is an alloy of iron and carbon. So again, that's a reference, but remember alloys, aluminum has several alloys. Copper alloys, there's a ton of different alloys out there, but steel is an alloy. Okay, bronze is an alloy of copper and tin. Remember we were just talking in the last slide about mixing copper. When you mix copper and tin, it makes bronze. That one will be on the final, so you don't have to remember it right now, but I put it in there as an example of alloys again. So you don't have to put that one to memory just yet, but you will need to eventually for the final. Okay, solutes are also called alloys or alloying elements. It's the second meaning for alloy. So and now this is a test question. It's actually underlined. Two definitions for alloy. The dissolved metal material and the solid solution that is made up of alloys and solvents. Now, the best example why they have these two, and what I've found out in industry, I worked about 10 years in industry, as you guys know, and I worked with metals and things like that. And when we talked about things in the shop, when we talked about alloy in the shop, it was number one, the dissolved metal material, okay, like a steel alloy or a different, copper alloy. However, when you start talking to scientists, material scientists, metallurgists, like if you went to FPM heat treating, there's a number of heat treaters out there in this area. They actually have metallurgists on staff, and sometimes they might be referring to alloy as a solid solution that is made up of alloys and solvents. So just be aware that it could be, they're pretty much very similar, but in the same token, just be aware there's a little bit. The first one is the one we use most commonly. Those of you in welding, those of you in manufacturing. Okay, so as for the assignments for next week, all right, read chapter 3. Okay. Do the questions. Now I only give you 5 questions here, 1, 5, 12, 21, 24, and they're at the end of chapter 3. So just go in your book, after you read chapter 3, go to the questions. And you don't have to type out the questions, just type out the answers. You could even send them to me in an email using your phone. Or if you want to, if it's easier for you to write them out on a piece of paper, take a picture and send them to me. Just make sure you put down at the top your name. Well, actually, your name isn't a big deal because you're sending it via email, but make sure you put down the chapter. Now, the reason I need the chapter number is because I don't ask you for the questions. And so sometimes if someone's botched all the questions, it's really hard for me to figure out, like, wow, what chapter is this? Because remember, I'm all about, like, if you're a procrastinator and you want to get these to me later, that's cool. I want to give you credit for it because some of the best workers I've ever seen are procrastinators. So I don't want to fault you for that. But when you get in industry, just note that you got to make sure you get stuff done on time. But anyhow, I'm very forgiving as far as that goes. So just please put in the chapter number if you send it to me, because I might send it back to you, because I might read the questions. They might be worded in such a way that I'm like, whoa, what are we talking about here? So this one wouldn't be too bad because it's 5 questions. So, but most of them have, there's a dozen questions, most of them. Okay. All right. So do those questions. The week 2 video questions, we're starting this up now. All right. Google a metal of interest to you. All right. Tell me 3 interesting things about it. So you can write these down. Okay. Give me a brief history, a couple sentences. Don't just copy and paste. That's why you could just keep it really brief. Just type it in yourself. If you're going to copy and paste, just make sure you put in quotes, because then it's not that big of a deal. But put a little bit of effort into it, because I want to make sure you're reading it, because this is really fascinating stuff. Metals are amazing. And you have 95 known metals to choose from. Okay, choose something exotic, because osmium, that's a really cool one. Check it out. Read a little bit about it. You'll find that they think there are some scientists think that the core consists of a lot of this stuff, and it's one of the heaviest metals. It's the 2nd heaviest metal. Try and find the first heaviest metal, and I'll tell you what, I'll give you an extra credit, and put down extra credit on it. If you find out what that heaviest metal is, put it in there. I'll give you an extra 5 credit points if you could do that, and put it in the same grouping. Okay, but anyway, osmium, really heavy stuff, heavier than gold. I think it's like twice. It's been a while since I've read about it, but really cool stuff. Look up some of the exotics for sure. Okay, and just one of them, and just brief history. Don't give me a whole dissertation. All right, 2 special properties of how it's used. So basically, what is it used for? Like if you chose gold, which gold is so boring, please don't choose gold. Copper's boring, aluminum's boring. I mean, they're really cool, but I know so much about them. Tell me something I don't know. Like, look up one of the weird ones and tell me about it. And basically how it's used. Like cobalt, for example, I was talking about that. You know, we have it, and it's true when it looks like a crystal, it's like blue. It's used like in paints and stuff. It's beautiful color. You know, you could find stuff out, other things like lead oxide is red, and how dangerous it is. It's like it's really bad stuff. Find out anything, you know, that you want, put it in there. Get interested in it. I think you'll have fun once you look this up, and then you won't believe, you'll be able to tell your family around dinner, like, what did you learn today? And tell them a little story. You know, I learned cobalt, you know, a little bit about it, or I learned about osmium. Did you know that there, you know, most of this in the core? By the way, the reason it's in the core is because it's so heavy. They think when the Earth formed, it fell through the crust, and it's down in the center of the core. That's why. Anyhow, that's why it's so fascinating to read about this stuff. Okay, I'm babbling. My apologies. By the way, if I babble too much, just accelerate. This is a YouTube video. Down in the lower right, you could go to the settings and play it at 1.5 or 2 times or 1.25 to get through things a little bit quicker, okay? Now, also, I want you to look at how it's found or mined or created. Some are synthesized, like right here at Fermi Labs, which is down the street actually from the college, not exactly down the street, but only a few miles away. They can actually synthesize some of these things, and they only last for a fraction of a second. When the collider, the super collider, like in France, I think they have been able to make some and synthesize some metals that way too. All right, so how it's found, mined, and created, and keep it short. I mean, if you want to give me a dissertation, that's cool, but you don't have to put a lot in this. You're going to have much more fun if you're just looking for a cool couple of facts. And Wikipedia is actually a great resource. You don't have to look it up. You don't have to go to the library. Of course, in this day and age, we don't want to with COVID. But, you know, there's a lot of really neat things. Even those of you who look up properties of silver and its antimicrobial capabilities. Even copper is antimicrobial. Speaking of which, when we're talking about COVID lands on it, it dies a lot quicker on copper than it does other things. Same with silver. Okay, anyhow, well, that pretty much finishes up. This was kind of a short week, so, but definitely do your reading, do the questions, get these to me, and keep tabs on D2L, see what's going on there. I'll talk to you later. Take care, guys.